Hello, my name is Mrs. Heiss. I am a junior high math teacher, and today we're going to be going over fractions, how to add, subtract, multiply, and divide fractions. Now, why am I going over this? One, because my 7th graders are covering this. Two, this is actually one of the basics that you need to know in math that a lot of people seem to struggle with. So I'm going to explain a couple things like why we change common denominator, why we change denominators, why do we even need them, and when to do each action. So let's look at this first. So I have 1/2 plus 3/4. That's a nice number. What I want you to think about is 1/2 of a pizza. Okay, so I'm going to make a half. Here's half of my pizza. That's a very nice pizza. And then I have about 3/4. So it's going to look something like that. That's a very nice pizza. If I add 1/2 to 3/4, if I add this slice of pizza to 3/4 of a pizza, what am I left with? More than one pizza, right? Because, let me see if I can do it this way. I'm going to have the half here, and then I'm going to have, let's make it yellow, more than half here. It's beautiful. It's art. What most people try to do is that they'll go 1 plus 3 equals 4. 2 plus 4, 6. Now, 4, 6 can be simplified to 2/3 because both numbers are divisible by 2. Now, that tells me if I add half a pizza and 3/4 of a pizza, which should equal 1, because let's have that overlay, should be more than 1. So why does this tell me I'm going to have just over half? 2/3, 67% of a piece of pizza. That's like, I don't know, let's see if I can draw it. That much pizza. That's not a lot of pizza. That's not even 3/4 of pizza. But if I'm adding a half and 3/4, I can't get something that's smaller. So that's why we change the denominators. You want that bigger piece of pizza. You don't want the smaller piece. You want the bigger piece of pizza. So, in the situation where I have 1/2 plus 3/4, I'm going to find something called the least common multiple. Let me write that down. Least common multiple, or better known as the LCM. The LCM is the least common multiple. So a multiple is just what is 2 times 1. Well, 2 times 1 is 2. What's 2 times 2? 4. Any number multiplied by 2, what is the multiple? What is the product? But specifically over our 2's table, or in this case, the 4's table. So I want to find the least common multiple of 1/2 and 3/4. Okay? The way I'm going to do it is see which one of our multiples line up. So for my 2, I have 2, 4, 6, 8, 10. Okay, we tracking. What about my 4's? We have 4, 8, 12, 16, and 20. I want to see if any of them line up. So I'm going to change my color again and see if I have any matching numbers. Well, my 4's match, my 8's match. But which one is the least common? It's my 4's right here. So what I'm going to do is I'm going to try to make it a common denominator. 2 times what gets me 4? It's going to be 1/2 multiplied both sides by 2 plus 3/4. Why is 3/4 left alone? Because my least common multiple is already there. It already has the 4 in the denominator. This is going to turn into 2/4 plus 3/4. Now that I have my least common denominator, my least common multiple, I can add. I leave my denominators alone. They stay 4. No matter what, they stay 4. That's the one nice thing. You never have to worry about the denominator. But 2 plus 3 is going to be 5. Now this is what we call an improper fraction. And you are allowed to change the format of this if you don't like this. You're just basically going to do a division problem. How many times can 4 fit into 5? It can fit in 1 time. Again, like I said, always keep the denominator because we don't affect that pizza size. Bigger or smaller, we don't want to make it smaller when it's actually supposed to be this big. Now, how many times 4 can go into 5? 1 time. What's 4 times 1? 4. All right, what's 5 minus 4? It is 1. So anytime you do it backwards, please know you're multiplying your denominator by the whole number, and then you're adding your numerator to the answer so far. So that's how you do this. But what if we did subtraction? And I'm going to switch the order so we don't get any negative numbers. Good so far? Please feel free to pause this and go back to the information that I'm teaching you guys. So let's do this. I'm going to change my ink. Now let's do the same numbers as before, but I'm going to switch the order around so we don't have a negative number because negative numbers are icky. I'm going to do the exact same process as I just did with the addition, but we're subtracting. So the LCM, these come in multiple. So we have my 2, 4, 6, 8, 10. Then we have 4, 8, 12, 16, 20. I'm going to find my LCM. Which one's my LCM? My 4 or my 8? Going to be my 4. I'll write that down here. Now that I have 3/4 minus 1/2, do I need to multiply this fraction by any number to get 4? No, because my denominator is already 4. So I'm just going to put 3/4 minus. Does anything need to happen to my 1/2? Yeah, because the denominator has a 2 there. My denominator should not have a 2. 2s are bad. But 2 times what gives me 4? It's going to be times 2 times 2. So what's 1 times 2? 2. 2 times 2? 4. And now we have common denominators. What is 3 minus 2? 1. I keep my denominator same. My answer is just 1/4. And this does not end in improper fraction form, so I don't have to change it to a mixed number if I so desire. This could be a good final answer. All right, we feeling good so far? We feeling good? Now we're going to go over multiplication of fractions. Again, keep it with the same numbers as before. We have 3/4 times 1/2. Now, sometimes you will see multiplication represented by a raised dot. That is a common way so that, especially when we get into the algebras, it does not look like 3/4 x 1/2. Because x could be a variable. So we avoid that. So don't do that. So I have my raised dot here. That's why I have it here. This is what we're doing for my 7th graders and my 8th graders. So what's 3 times 1? 3. 4 times 2. That's it. That's the most straightforward process, operation that you will do with fractions. You're just multiplying straight across. Do I need to simplify this anymore? No. Can I make this smaller? No. It's perfect the way it is. That's all you're doing, even if it's it would still be same process. This one we could simplify a bit to words are hard. To this, but it's the same thing. Now, what about if we were doing division? So I have 1/2 divided by 3/4. Now what we're going to be doing is something called keep, change, flip. So keep, change, flip. KCF, or keep chicken fried, as my kids say. We're going to keep the 1/2 the way it is. But I'm going to change that division sign to a multiplication sign. And then I'm going to flip on its head my fraction right here. Keep, change, flip. Keep, chicken, fried. 1 times 4. 2 times 3. 6. Good. I can simplify this, which all that means is see how these numbers are both divisible by 2? Instead of giving it 6 slices, I can just make it 3 big slices. It's the same thing. 2/3 or 4/6. I would take both. But that's all that we're doing with orders operation for fractions, for adding, subtracting, multiplying, and dividing by fractions. Some funny way that you will actually see division with fractions, and I actually want to bring this up, is you'll see 1/2, that's a beautiful half. You'll see it represented like this. Because a fraction is just a division problem itself. We're saying that there's going to be 1 part of 2. That's all we're saying. Or 3/4. We're dividing the amount of pieces. It's beautiful. It's art. We're dividing the pieces. So if something's presented as a bigger fraction, you're just dividing these fractions by each other. That's all it's asking. This is called a complex fraction. I will write this down. A complex fraction. So based on this is another way we can actually do division, or you'll see a division problem written with fractions. I hope this video was informative and helpful to you guys, and I hope you have the most wonderful day today. All right, see you later. Bye.